So I have made a pretty big mistake in my divisibility proofs, and some of you might have noticed that I've renamed, I think it was 4 of my videos flawed proof, and I've changed the title, the thumbnail, and the description, and I re-uploaded those with a slightly different video. And what was the mistake I made? Well, the mistake was actually in my definition of divisibility. When I explained divisibility, when I defined it, and when I used it in the proof, the most important part was when I used it in the proof. I forgot to add something to this, and can you guess what it is? Well, it was the fact that this is all true, but I forgot to say that x here can also not be 0. Why is this such a huge flaw in those proofs? Because when we say in a divisibility proof like the ones I've done for all integers a, b, and ab, where a divides b, I'm saying for all integers a, which would include things like 1, 2, 3, ... those integers. It would include negatives, right? But it would also include 0. So this statement would include 0. And why is that a problem? Well, when you try and take the left-hand side, we're looking at the left-hand side specifically is where this condition is going to hold. When you take something on the left-hand side to be 0, and you want to say it divides by something on the right-hand side, you are arguing that, let's say this right-hand side is some integer k, you are going to be arguing that k is a multiple of 0, or k can be written as 0 multiplied by some integer m. And this is obviously not true, because let's take, for example, let's take 0 divides 1. We're saying 1 can be written as 0 multiplied by some integer m. Well, this is obviously not true. 0 times anything is always going to be 0. It cannot equal 1. But let's say you didn't know that. Let's say you wanted to find your m, just like you would, for example, if you wanted to compute what 2 divide 1 is, you would say 1 is equal to 2 times m. If you want to find what your m was, you would simply rearrange. Is that true? That's not true. My apologies. If you wanted to say something like 2 divides 4, you can simply say, okay, well, 4 is equal to 2m. If you want to figure out what your m is, here m is obviously 2, but if you don't know that, if you have some long expression, well, you could then rearrange for m, right? You could say it's equal to 4 over 2 is equal to m, which is equal to 2, which is clearly an integer. But in this case, if you want to rearrange for m, you're going to have to argue 1 divided by 0 is equal to m, and you can't divide anything by 0. This is undefined. So because it's undefined, this cannot possibly be an integer because integers are defined. So it's the same here for any integer k. You're arguing k can be written as 0 times m. So if you want to find m, you're saying m is equal to k over 0 is equal to m, which you can't do. You can't divide anything by 0. So this is a huge, huge flaw in my proofs because I'm saying for all integers, and I'm not making the case that it can't be that one of them is not 0. All integers except for 0. Because that is something that people always think about is 0, positive, and negative. That's one of the big 3 fundamental cases you think of when you think of integers. And it's very, very vital to say that if it's not true for one of the cases, you have to say that. So just wanted to correct myself on that. I did re-upload the videos correctly, and I've instead created a playlist with my flawed proofs where if I made an incorrect proof and I've already edited it, uploaded it, and it's been up for a while, I'm simply just going to rename it, re-thumbnail, re-description, rewrite the description, and just post it in that playlist. So maybe it's more of like an exercise for you to go through and see what my flaw was in writing that proof. But there we go. I just wanted to point that out and admit to that mistake.